Okay, I'm up at Dallas Makerspace, and this particular concept came up in this very electronics lab as a point of discussion. At that point, it was just, how many blades do you need for, well, obviously for a quadcopter you need 4, but what's the minimum number of blades that you need to fly? And we have seen recently, a lot of counter-rotating craft emerging. The question came up, well, what about just one? All right, so I had suggested that, or I had asked the question, and another engineer had said, well, maybe you could do some sort of thrust vectoring or something to offset the rotation. And that resonated with me. That seems to make sense. Okay, so I have actually gone to the hobby shop because I wanted to know if this would even work or not. I read online that there's some vector, torque vector or something. There's some inertial vector when a motor spins and powers a blade. And the reality is, I don't think I fully understand it. I think I'm about to learn about a $300 or $400 lesson, but just in the off chance it happens to work, it would be cool, because then that's the cheapest way I can think of to get up in the air would be just one single motor. All right, so the idea for developing the motor was, or the craft was, well, just the simplest thing possible. This is a Carnegie motor. It's I'd have to look up the specs on it, but it's one of the beefier, more well-known outboards that you'll find at hobby shops. Usually, it's quite expensive. I picked up this motor for under $20 because it had been opened already, so I'm pretty happy about that. I got a 500 milliamp hour LiPo charger that matches that particular battery, and then really the meat of it is right here, these 4 servos. So what I'm going to do is I'm going to make, I'm going to come up with some sort of assembly here and make 4 flaps that take the vectored, or take the air that's flowing down and kind of redirect it a little bit, enough to generate a force through the flap itself. So hopefully, I'm hoping that it offsets the rotational effect and can keep it from rotating, and then I can get control of it in this fashion. So the other pieces of equipment that are of interest here are this guy right here. This is the prime piece. This is the ESC. Basically, this will plug into the ESC. The ESC will generate a 5-volt supply back, opto-isolated. This 5-volt supply is used to power all the additional electronic circuitry other than the main rotor. The main rotor will come off. You can see this Carnegie motor has 3. It is a 3-phase. This is a brushless DC motor. No, it's a brushless motor. I'm not going to say DC. It's a brushless motor. What do they call it? Oh, there's a particular name for it. The ESC handles the control signals for that, and I am not that expert on motors, so I've been reading about it recently and have been just absolutely perplexed with how many different types of motors there are, electric motors. It's a whole field of study in and of itself, so I'm kind of coming up to speed. But this guy right here will actually power those 3 heavy signals to the motor. And basically, there's some control signals that you send back in, and I'll use, in order to have control of this thing remotely, I'm going to use this guy right here in conjunction with this controller. So this one, they're saying that this thing is so powerful that it can be, it's at the point where you can no longer see your craft. That's where that no longer reaches. So anyway, I've got 4 servos on here and a throttle. That's all I need to fly this craft. So this is what I got, and that's my video. I'm interested in anybody have any ideas as to whether or not this is going to work. I might actually put a poll up here on makerspace as to who thinks this is going to work. And if anybody can beat me to it or come up with a better idea, I don't know. So anyway, we got I think there's a wild hog infestation at Dallas Makerspace and Electronics Lab. I don't see them, but I definitely hear them.